Hello, everyone, and welcome to another episode of the Day Zero podcast. I'm Spectre, with me is Z. Today we've got some P0 disclosure policy changes, lots of Windows exploits, quite a few, and some Snapchat attacks. So we'll get into the P0 policy changes first. So Project Zero has revised their disclosure policy as they said they would in last year's post. This year's changes have a focus on, quote, improving the current industry benchmarks on disclosing timeframes and adding a period for user patch adoption. So the changes aren't too major. For the regular vulnerabilities, the 90-day disclosure deadline remains in place, where issues that are left unfixed for 90 days are released immediately. But details about the issue come out 30 days after the fix if one is implemented, which means technical details could come out earlier if it was fixed earlier than 60 days into the disclosure period, or it could come out a bit later if it was more towards the end of the 90-day disclosure deadline. And again, that's to allow that user patch adoption. Similarly, with issues found in the wild, the 7-day disclosure deadline is being left in place, but if the bug is fixed within that 7-day window, the technical details won't go out after the 7 days immediately like they have in the past. There's going to be that 30-day period. So, yeah, I mean, the changes aren't too major. They're mostly like centered around that initial premise of just trying to give users more time to patch.
Yeah,
right?
Which they end up mentioning that they introduced that 30 days, or basically they've included the patch time as part of their policy, because it seems like while the intent last year of the whole 90 days was if a vendor wanted to provide users time to patch, they would prioritize getting that patch out earlier so they would fit within the 90 days. And what they found were that vendors just weren't really either grasping that or being willfully ignorant of that aspect, and then, kind of maybe not complaining. I don't know what the actual communication looked like between Google and security teams, but there seemed to be a disconnect in understanding, like, you should prioritize getting that patch out earlier if you actually want to give users time to patch instead of just 90 days. So that's kind of why they've decided to include that. I just find it interesting that there was that disconnect between their intent and the vendors. This definitely makes it a lot more clear. Like, I think it's a good move. And this actually just reminds me of the complaints I've had towards HackerOne, where HackerOne is in kind of that really good position to kind of walk clients towards having a better, more mature security process. Whereas in this case, Google's just like, no, this is our disclosure policy, and like, they're slowly inching towards what is a more ideal policy. They even mentioned here, like, in the future, they're doing the 90 plus 30 right now, giving more time than jumping straight to what they want, which is 60 plus 30. And then talk about reducing it down to 84/28, so they fall on numbers divided by 7. So basically you're not ending up with deadlines on a weekend, ideally, unless they do a disclosure, like the initial report on the weekend. I think it's a good move. I like seeing Google making these incremental updates to it and explaining why. Because honestly, since Project Zero first launched with their 90-ish day policy, in the years since then, because that was back in, when was Project Zero established? I want to say 2014, might have been 13. Since then, 90 days has become almost an industry standard for a lot of people. So they've been, in a sense, kind of the market leader on this, if you can call it that. So I appreciate the fact they're being a lot more open about how they're coming about these numbers, so that other people can kind of start following it and understand where it's coming from.
Yeah, so I just looked it up. July 2014 was when Google Project Zero was founded. I initially searched up Project Zero established, and I got 1967, so that wasn't the Google Project Zero, I don't think.
Yeah, well, they were doing the vulnerability reports way back.
They were way ahead of their time. Yeah, like you said, I think it's a positive move. I do find it interesting they speculate on what they could be moving to for 2022. They say, for example, based on our current data tracking vulnerability patch times, it's likely that we can move to a 84 plus 28 model for 2022, right? So, and yeah, that's what you're talking about a little bit with the deadlines not falling on weekends. So yeah, I mean, that it seems like a positive move. It's cool that we could end up getting vulnerability details earlier if companies are kind of proactive and get it fixed quickly. That said, I think it's probably going to fall more on disclosures happening later than sooner, just based on the way that we've seen things go. But
yeah, I mean, vendors are almost certainly going to push off fixing things. That is what they tend to do. Push it off as long as possible, give themselves as much time as possible. That said, by establishing that patch time in with their disclosure timeline, in this case, yeah, they are extending it out. But like they mentioned, their goal is reaching that 60-30 split rather than the 90-30. They're just starting here. So in a few years, hopefully, they'll be able to reach a point where they're hitting it closer to that 60-30 split.
Yeah. So, yeah, some good moves by Project Zero. And can't really find many issues with the new policies. I think they're a good step.
Thanks, Belika, for your 7th month of subscribing.
Oh, yeah. Welcome in, dude. All right. So our next post is around WhatsApp on Android and 2 vulnerabilities that can lead to RCE and leakage of noise protocol keys using something called a man-in-the-disk attack, which is basically a man-in-the-middle where you use your access to the external storage or SD card to leak data. It's worth noting that these attacks should not be possible on Android 11. Android 10 introduced scope storage where you were kind of sandboxed to your own content on external storage to prevent exactly these kinds of issues. But on 10, it was somewhat permissive to allow like a graceful transition period for developers. So these issues affect Android 10 and lower, but not Android 11. That said, a lot of users aren't running Android 11 or probably not even Android 10. So that doesn't really take away from the potential impact of the vulnerability, right? So what are the vulns? It basically boils down to the fact that WhatsApp had TLS session state information, including secrets, cached to the external storage to utilize TLS session resumption, which they go into in some detail in this article, but I don't think it's too relevant that we need to cover it.
Yeah, they go into a lot of detail in this, talking both about the session resumption information, the Chrome CV that they kind of use to exploit this. But really, the vulnerability is simple. They're writing sensitive information to a publicly accessible location, namely the SD card. Writing the crypto information out to the SD card where somebody could read it. It's simple, but this is a very long post for a fairly simple issue.
Yeah. So, yeah, I mean, they mentioned a few ways you could utilize that for an attack. They mentioned you could pull it off by phishing using a Chrome same origin policy bypass, which was a 2020 CVE, so that Chrome could access the media store of other applications. So yeah, the 2 vulnerabilities is basically the same issue, but on different endpoints, being TLS 1.2 for client to server communication and TLS 1.3 for end-to-end encryption for chat communications. So with the TLS 1.2 MITM, you can get an RCE. And that basically is based on the ability to send downloadables from the server, such as doodle emojis or photo filters or whatever, which are downloaded by way of zip files. So if you just replace the URL where it downloads from, it can download a malicious zip. And WhatsApp uses Facebook's Super Pack for distributing native libraries, which are packed with the application. So you can use a malicious zip file to replace those libraries to get your own code ran when they get loaded in. The second attack was leakage of noise protocol keys for end-to-end encryption if you can man-in-the-middle TLS 1.2 and 1.3, which their attack there was basically intentionally triggering an out-of-memory exception to get the application heap dumped and sent to the server through crash logs. And the application heap dump that was sent to the server would include decrypted conversation information as well as the noise protocol key pairs. There was no filtering on the crash dumping to not dump really sensitive information. So yeah, they basically triggered that out of memory exception by using the MITM to tamper with a response that gets read into the string buffer for getting stickers. And then yeah, they would just pull the crash dump while it was being sent to pull the keys out of it. So yeah, some cool attacks. The post does go into a bit more detail than I think it probably needs to. But it is there if you want to check it out and get some information about how TLS replay works, or TLS session reuse. These vulns are a good example, though, of why that defense in depth in the form of scope storage is necessary. And it's actually a little bit surprising that it took Google as long as it did to do scope storage. Like Android 11 is pretty new. It just came out September of 2020. So yeah, I guess they were a bit late on that front. So yeah, I mean, just some crazy issues. And like I said, I really don't know why they're sending the keys and the conversation info and just a massive heap blob to the server. I feel like they really should be doing some kind of filtering on the crash dump process. But
I mean, they should be, but what do you filter? Like, do you... Because, like, your crash dump share just, like, what's in memory at this time? So you go through and you look, okay, what values are you going to compare to actually look for it not to dump? Or what memory region should it not dump? On one hand, you could say it should remove some of those things from memory. But given the fact that you're going to be... like, those conversations may be active at the time of the crash. Like, they have to, at least somewhat, be available, be readable in memory. So I think it would be more, rather than filtering, pulling out the relevant information, but that kind of reduces the usefulness of a crash dump. It's a hard problem if they're doing the crash reporting.
I think the keys, at least the keys, should be put into like an isolated heap arena, where it's like if the heap gets dumped, then that area of the heap is excluded.
So the flip side would be including some of that, but encrypting it before it gets sent out using public key crypto. That way it can't be read by a man in the middle. You can definitely still have some issues where, okay, but now WhatsApp is able to read these supposedly end-to-end encrypted messages, so there's still some issues with the crypto aspect. It somewhat feels like they just shouldn't have the feature to begin with.
Yeah. And for what it's worth, like, doing public key crypto on crash dumping functionality is not uncommon. It's funny, Sony actually got hit with the same issue on the PS4. Fail Overflow managed to abuse the crash dump functionality of the PS4 to be able to pull crash dumps because they weren't encrypting them. So they had to go back and retroactively add encryption, or not retroactively, but in newer firmware updates, I guess, add encryption onto that. So yeah, I mean, I guess crash dump functionality is just one of those things where developers don't necessarily think about it as a potential as a area it can be side channeled, I guess, but it absolutely is. And yeah, I guess it's just somewhere that people don't really think about, so that's why they get attacked as they do.
Yeah,
so.
I mean, it kind of comes down to the same idea with just overzealous logging, where applications might accidentally say log a password, or like log the entire request, and it just happens to happen during like a password request, or not, or like during a login, like something that includes a password. That's kind of the same issue, or feels like the same issue as these crash dumps. It's just overzealous information collection.
Yeah, exactly. So not a super complex issue, but a pretty impactful issue, basically. All right. Up next, we have a blog post from Positive Security about multiple bugs they found in popular software like cryptocurrency wallets, Mumble, Wireshark, Telegram, Nextcloud, and others. One of which we've actually covered on this show a month ago on episode 69 with Wireshark. As such, we'll probably just briefly cover this one because all the issues are based around the same premise, and that's allowing arbitrary URLs without filtering out the scheme at all. So by allowing an attacker to control the URL that gets shown as like a clickable link or whatever, and not rejecting things like the file scheme or SMB or SFTP or whatever, that can lead to whatever action is attached to that filter getting ran, right? Whether it be like an executable getting ran or a Java archive or whatever being downloaded and ran. What's cool about this post isn't so much about the issues, as they're pretty straightforward. It basically comes down to filter your links. But they also have this central listing of like the common operating systems and the URL opening behaviors they have. So that includes Windows, Linux-based operating systems, and macOS. And they give kind of an overview of the types of places they found those vulnerabilities. So I think the OS link behavior is probably the most useful part of this post to me.
Yeah, I found it just interesting some of the place that they found it was getting used. Actually, in particular, I thought the VLC issue was interesting. Let's see if they have a link right to it. I mean, they have a link to it, but I apparently can't actually, or couldn't click on it. The VLC issue ended up being in when you would have a playlist. I'm just trying to skip ahead here for those of you that are watching. And then you go show containing folder, and that happens to do the open. Like, that's not where I would have expected it to be trying to do that. Like, it makes sense that it's trying to open that location that way. It was just a little bit surprising. Like, it's not somewhere I've even thought of as being a risk to click, showing containing folder. So I found that one interesting. But yeah, as a blog post, it's just a lot more on the research side. Just here's an overview of everything. Not entirely surprising. We've seen this sort of issue before. We've talked about these types of vulnerabilities before. So it's not necessarily new. It's just an overview of it. And like I said, it gives the information kind of cross-platform or across several different platforms.
Yeah, and like what I've kind of said before is with these types of issues, the impact is usually pretty limited if it's just like a clickable link, because in most cases you're going to be able to see the link and see, okay, that's a really fishy URL. I'm not going to click on that, hopefully. But I mean, there are some cases where it's not as cut and dry and it could be more impactful. But yeah, I mean, a lot of these applications, like with Telegram and Wireshark, like when we covered it at the time, and like Bitcoin and Dogecoin wallets, like they mentioned, you would have to do social engineering in order to get somebody hit with that. So like not super practical issues in a lot of cases, but issues to be aware of nonetheless. And like I said, I think the information on the schemes with different operating systems is useful because those schemes aren't really standardized between operating systems. So that it's easy to like not be aware of how dangerous they could be. So
yeah, I mean, ultimately, applications just, like, if you're going to give that click-through ability, just look and make sure it's actually, like, HTTP, or it's actually more or less what you're expecting. Just validate what you're sending out to it. I think I saw some comments, maybe it was on Reddit to this or something, or maybe it was even in this post, they suggest the operating system is kind of at fault for even doing that.
No,
for providing it. Yeah, I wouldn't blame the operating system for this. I think it's definitely a case of applications using the API or misusing it in these cases.
Yeah, exactly. It's up to the applications to filter like links that are going through it. That's not the fault of the operating system.
Yeah.
All right, so we have a quick issue in an open source project called Infrabox, which involves log injection, which I know was what you found interesting about this topic, Z, so I'll let you go ahead and take this one away.
Yeah, the actual vulnerability itself, or as the name implies with log injection, you're able to control what's being written to a log. Not an insanely damaging issue, like you're not getting code execution, you're not revealing any sensitive information out of it. You just have this JSON request to this API/log endpoint, and the actual value in log here just gets written out to the container name .log. So you've got path traversal there also, has to end with .log. I don't know how deeply they looked into, like, if null bytes or something could cancel that, but in theory, it's going to be your .log files. So you can't just arbitrarily overwrite anything. And as an issue, I just wanted to kind of shout it out as something that it's difficult to test for if you're in like a bug bounty situation for log injection, unless you can actually read the logs or if you have source access. So this is one of those issues that I think kind of gets overlooked and definitely gets downplayed. Because it gets downplayed, I mean, they shout out here kind of the ability to possibly do access on like whatever the log viewer is. That's going to vary. Most log viewers probably aren't going to give you access, but it definitely happens. But I do think one of the big issues there is as soon as you need to do incident response on one of these things, like on a vulnerable application, it's all of a sudden you can't trust the logs at all because somebody can just go ahead and inject any sort of log entry they want, make it look like anything happened before or after an attack. You can't trust any of the entries, and that is why I think log injection is a fairly important issue to at least consider, even though I think it gets downplayed quite a bit.
Yeah, it's not something we see too often on the show. I think we have covered one before in the past. Back on episode 48, we had an XSS through logging user agents in LeoStream Connect Broker. So yeah, like that's an example of one we've covered before, but it's certainly not something that's covered super often. So yeah, like since you can write the arbitrary contents to a log file, just like in that case, in this case, you can use XSS. And you could also like maybe do other things too, like fake log events of some kind.
Well,
maybe
yeah,
try to like bury something in the log.
The faking log commands is exactly what I'm talking about with doing log injection, is being able to tamper with those entries.
Yeah.
Because when you can do that, like now incident response can't trust anything that comes out of it, especially if this ends up going to like a universal logging system, depending on how well it's able to determine where the log source came from. You might be able to spoof logs from other applications and things like that. Of course, as an attacker, you also have a hard time knowing what your logs need to look like. There are challenges with that. But it's one of those issues that really, I think, needs to be there kind of for that in-depth protection. Because, like, your logs, at least in my experience, I am not an expert when it comes to, like, forensics or anything. In my experience, like, if you're doing incident response, like, that is a big thing that you're going to be looking at. Perhaps professionals maybe have some better tooling that I'm just unfamiliar with. That's completely possible. But I feel like logs are still fairly important. So I just wanted to shout this out as one of those attacks that it's worth considering, even if people are going to downplay it or ignore it on you.
Yeah, that's got to be like nightmare fuel for IR, I can imagine. All right, so up next we have two-factor authentication bypasses in Duo 2FA, detailed by Sean Kammerling. It says it was posted on January 28th, but it only went public recently, so it's one of those cases where the date that's on it is actually the date of writing, not the date of publishing, which is really confusing. But yeah, don't let the date deceive you. It's a lot newer than the titles and than the byline suggests. It details two 2FA bypasses. The first bypass was sort of a replay attack due to the authentication state not being tied to the user's session. So basically what you could do was you could capture your own legitimate 2FA request, block the response from reaching your device to prompt for authentication, then submit a 2FA request using the victim's credentials as an attacker, which they've presumably compromised. Then replace the session ID in that request with the session ID from their legitimate request, and that would get the Duo app to prompt for authentication using the victim's auth state instead of your own.
Okay, so I might have misunderstood part of it, but I believed kind of what was going on with that first request, the attacker one. When they grabbed the SID, that it would drop the request, so the request itself was never actually going to hit the server with their SID. They just copied their SID from that first request that went out. And then they copied that one into the victim's request, copied their SID into that one, let the request actually go all the way through that time. So the first time the SID was being seen was when it was kind of associated with the victim's account.
Yeah, sorry. So I was kind of conflating the first issue and the second issue. You're right. The first issue was on the dropping the request. My bad. Thanks for correcting me there. But yeah, that path was a bit racy because that session ID would expire pretty fast. So you would need to pull off the entire process in a pretty timely manner. But they found another variant which got around the problem, which...
Before you go into the second variant, they mentioned they kind of had to be quick about that with the SID, but this feels like something that could be automated pretty easily. Especially since you control the devices going through this. So just to be clear with this, it's a 2FA bypass. You still need to know the victim's credentials. You're just Duo provides the multi-factor authentication. They've got their own little system. It'll show you a little alert on their app, and you can approve the login there. So you still need the credentials. So it feels like something that you could pretty easily just automate, like a few, Python requests or something. Just automate these the login attempt and the other events going through there or something. Or maybe man in the middle. It's probably doing some sort of SERP pinning or something to make that a little bit more difficult. Because I feel like that's just within kind of their expected threat model. I don't know for sure, but I'd imagine they're doing something. But still, this feels like something you could pretty easily automate. So saying that it's racy or like they've got to move quickly, like just don't do it by hand would be the solution. Not we need a whole new vulnerability. I mean, I'm glad they included a second vulnerability there too. It just feels like maybe it wasn't necessary, like their problem with it. Like maybe if they include more information on why they couldn't automate it. But as is reading this, I just felt like, well, why didn't you automate it?
Yeah, it feels a little bit over-engineered in that regard. But they did go through the process of finding a variant that was more stable or wasn't as racy. The second method was kind of what I was getting confused with earlier. And it was on a slightly different part of the authorization flow. And it was, instead of attacking the request, you would attack the response, the 2FA response, which would contain a transaction ID or a token, which would be used to pull for the status of whether or not the user accepted the push request on the device. So you could basically start an innocuous dual auth request on an attacker device, accept it, intercept the request sent back to the server, then replace the transaction ID with the one from the victim's user account login and trick it into thinking the victim dual auth. And that method was more stable since it didn't have the same timing aspect. You had to beat the victim to using the transaction ID, but that's a lot larger of a race, and especially if you're automating it, like Z said, that's not even a concern, really. But yeah, you didn't have that aggressive expiry like you did with the first path. So yeah, like you said, it did feel a little bit over-engineered. There were a few parts of this where I was wondering, like, if the authorization flow is this weak, it feels like you could just attack it, like, in a simpler way.
Yeah,
but that could have just been that there was some information missing. I'm not sure.
That was kind of my issue, especially with the second one where it's using the transaction ID. It feels to me like because all you're doing, you're replacing the transaction ID, like you intercept the requests going out, drop in your attacker transaction ID instead of the original one, and it gets the response saying it's okay and it moves on. Is this not client-side validation? Like, that's what it feels like to me. And the only thing I can think of is, okay, perhaps it's doing something like you can only access each transaction, like after it hits a status okay. You can only access it like once or something. In which case, the fact that it's seeing it would kind of be okay. Or maybe it's doing something on the server side, like messing with your SID when you get that first response that isn't okay. I don't know. It's just the way they describe it, it sounds like you should also be able to intercept the response and just drop in that status okay and like status push, or like the status result success. Just being able to push that in feels like you should just be able to do that, and it should just work in theory.
Yeah.
So I don't know. Like, they don't really explain why it worked this way. Maybe they don't know. Maybe there's some to it. This looks to me like just that standard old client-side validation where the client is just looking to see this result success in the response without any concern over whether or not it's the right, well, in this case, transaction. But either way, it's just really suspicious to me. Obviously, it was a vulnerability. They reported this out. Like, I'm not questioning whether or not it's a real vuln. Something just doesn't add up. It feels like we're either missing some information or something's happening on the server, something like that.
It seems like the authorization flow is kind of weak on Duo's side. And to clarify, when I was saying that this feels over-engineered, I meant the attack, definitely not the authorization flow. The authorization, like, Duo's side was actually under-engineered.
I don't know if the attack would necessarily be over-engineered. If they're doing it by hand, it's just because they didn't spend the time to engineer like the script up in the case of the first vulnerability. So doing it by hand isn't really over-engineering yet.
No. I meant with going with the second variant.
Well, on the second one, though, they're just dropping in the transaction ID. it's a lot more intuitive, I guess, a lot more common to intercept a request than to intercept the response to a request. So doing the change there instead of trying to do it on the response, I think, is completely fair. Oh no, it doesn't feel over-engineered to me, but whatever.
So, to be fair to Duo, these issues were reported to them, and SensePost gave them some praise here, saying that they were pleasant to work with, which they said wasn't super common in their experience with companies. So, yeah, and it said like that raised their opinion of Duo as a customer, because they say they use Duo for authentication for their like company or whatever. So, yeah, it's always nice to see that kind of I guess feel good story coming out of the vulnerability disclosure timeline. The issue was fixed pretty quickly, from what I can gather. It was fixed within like a week or two. So,
well, so they have the report on December 14th, report to Duo, and on the 18th, Duo confirmed that the fix had been in place for a few days. So that's only 4 days, and then the fix had already been there for a few days, so it seems like they may have fixed it within a day or two, not a week or two.
Yeah, so even better. So yeah, we've kind of said in the past that like the response matters more than the original issue, I think. And in this case, while the authorization flow did kind of seem weak to me, like we were saying though, like it could just be missing information, but regardless, like the response was very positive. So yeah, good to see. All right, up next we have a HackerOne report about Grammarly in single sign-on authentication before it was made available to the general public. So that's good that it was caught early. Z, I'll let you kick this one off because I know you like the SAML aspect, which you've talked about before on the show, or touched on a little bit before.
I won't say I like the SAML aspect, but I figured at least I'm familiar with it to cover this one.
Fair enough.
Which,
all right.
I mean, the SAML aspect is somewhat central. You don't really need to understand all of SAML, though. Grammarly implementing their single sign-on solution, so you can integrate with other providers. I'm actually not sure now that I'm thinking about which direction things went. Should be interacting with other providers, though. Yeah, I can't see why Grammarly would be a provider. Anyway, so what would happen here is kind of a disconnect when an attacker, when you would log in. When you create an organization, you set up this entity ID. The entity ID is supposed to be kind of this globally unique identifier. Usually it looks something like a URL, or it might even actually be a URL, includes like the domain name of the provider, something like that. So, it belongs to that provider and it's globally unique. It seems like Grammarly might have kind of depended on the fact that it's globally unique, because what would happen is if you were to create an entity, create an organization, give it an entity ID that had a space at the end of it, but otherwise exactly matched an existing organization and their existing entity ID, then when somebody tried to log in on the original organization, it would do the proper SAML thing there, but then when Grammarly would look up by the entity ID, it would go and look up what organization to log the user into or add them to. And when it would do that, it would always pull up the entity ID that had the space at the end. My guess is that, it was like a database query. It would look up for this entity ID. And because the two were so similar, it would pull up both of them, but it's only expecting one result. So it would just take the first result and it just happened to like sort by the latest entry or something like that. So it would always get the attacker's version of it and add them to that application, or add them to that entity or organization. So that ends up allowing you, in theory, you could probably come up with some sort of authentication bypass with that, or like taking over an account. They mostly just had denial of service where users could no longer access their actual organization or any of the things in there. But yeah, I just thought it was kind of an interesting attack in that lookup, and they traced it down as seeming to be because of using a trim on the issuer to look it up. Either way, straightforward issue. Not really what I would expect, or really non-intuitive issue, though, I think.
It was a bit complex to follow, which is interesting because usually like HackerOne reports are kind of a quick to understand and cover, but this one was a little bit confusing, especially where, like you were saying, like you have more of the experience with the SAML type systems than I did. So I'm not gonna lie, I struggled through this one a little bit. But yeah, it basically just seems to be like a desync around how that entity ID is handled. And that could lead to DOS or user account compromise if they were already in the, or if they weren't in the organization yet and they were being added after the attacker organization was created. The researcher got a nice bounty for it, though. I think they got like 10.5K for this bounty. Yep. So yeah, it was a very high paying issue. But yeah, a little bit complex to follow, but cool issue nonetheless.
Yeah, actually, since you mentioned that, I'm just pulling up, or trying to pull up at least, what Grammarly's usual average bounty is only 200 to 300. So that's quite crazy, a bit higher. Yeah.
Apparently, though, they do, on the focus scope, pay up to 20K on critical, which is also surprising. I didn't realize Grammarly would go that high, but yeah. Interesting. So, PT Security, PT Swarm, they put out a post about a bunch of vulnerabilities they found in Cockpit CMS. A total of 4 NoSQL injections, which were all pre-authorization, and a 5th issue, which was a authenticated PHP injection. So the first issue they cover was in the auth check endpoint for authenticating users. They take a user-provided parameter of the username and they pass it directly into a filter object, and they don't do any sanitization on it, which means you can embed an object with MongoDB operators into the parameter.
Sorry, just going to add in, for what it's worth, like when it comes to these NoSQL injections, this is the most common way you're going to see it. Is usually it's something in a filter where they're intending to just pass in the string. So you filter by the filter key and then it takes the string from there. And when they don't account for the fact that you can create an object, that's where you get the injection, because you can start doing matches by a ton of other options, such as the regex, or I think they use EQ as one of their examples. They're like, you can do a ton of other comparisons than just the equality against a string. So I figured I'd just shout, though, like that's kind of how MongoDB works in this case. Just something that's often forgotten about and the root cause of these sorts of injections.
Yeah, so the injection is a blind injection, which they get around by getting a warning displayed by intentionally passing an array for the password parameter. They note a few ways you could take advantage of this injection, such as using the EQ operator to brute force usernames and side channeling with the warning. If the warning is triggered, the user exists. If not, the request was successful and says the user wasn't found. Another way was using the regular expression operator for another brute force. The most interesting way by far, though, was using the func operator of the Mongo Lite library, which gets used, which basically allows you to call any PHP function with a single parameter, which would include var dump. So you could use var dump and just dump all the users in the database. So yeah, I mean that was definitely the most useful way.
I mean, I feel like an attack there that I know they cover something else that uses eval, but having it call as a func, I mean, I don't know, maybe the plugin itself won't let you do this, but having it call eval of all the usernames,
I could see that being put on like a danger list where it won't call that.
Yeah, I could too, but I could see it doing something like that. Yeah.
Yeah. The second NoSQL injection was the auth request reset for creating password reset tokens. Again, it's the exact same issue, no checking on the user parameter. Third and fourth issues were in the reset password and new password endpoints. Again, same issue, but on a different variable. It was for the token parameter that went unchecked. And that time they could use the func operator trick to not dump usernames this time, but existing tokens from the database, which is a lot worse. So with the ability to chain together one of the first two issues and one of the second two issues, you could dump valid usernames and valid tokens, which gives you all you need to be able to compromise user accounts through the API, because you can now use the API with the token you have to dump user account information. You can brute force the password hash and reset the password with the reset password endpoint, which can then lead to RCE, because Cockpit has a Finder component, which is basically it's like a file explorer, file uploader, and you can upload a file which includes a web shell, for example. Final bonus issue was a PHP injection when parsing filters on the accounts find method. which will take a user-provided filter and use it to build up a query that gets passed to eval, like Z was saying earlier. Though, like, this endpoint does require authentication, as I said at the beginning of this topic. So it's not unauthenticated like the others, and thus I don't really know how useful it is because, like they pointed out, if you're authenticated, you can already upload a web shell. So being able to execute PHP code through that manner doesn't really escalate you, as far as I can read, but it is an interesting issue to point out nonetheless.
Yeah, I mean, it's another route to the same thing. That said, I do want to call out that the vulnerability itself is in the fact that it reflects the key value out of this dictionary. I don't know, there's just some, because so often, you're going to attack a value. You're going to attack the value of the value, not the key. So I don't know, I just like seeing the vulnerabilities, even though this one, its impact is kind of mitigated by the fact that you can do this elsewhere too. It's not the only way of getting code execution. I just kind of like seeing it when they have such a vulnerability where it's the key that's the issue, where you've got to test, random things in the key instead of the actual value there. I don't know. I mean, it's stupid, but I just think it's such a fun place to find issues in.
Yeah, it's kind of a nice change of pace. So yeah, lots of vulnerabilities and details on how those vulnerabilities could be abused in this post. In terms of timeline, turnaround was very quick. First set of issues was reported October 14th and fixed 26th. And then the second set of issues was reported on March 15th of this year and fixed March 17th. So within 2 weeks on the first set and within 2 days on the second set. So yeah, quick turnaround. Our next topic is a build container escape for Bitbucket pipelines. Z, I'll let you take this one away because I was a bit late to getting to this one, so I don't have a good summary on it, so I'll let you take this one.
Yeah, so this one was also a little bit... Well, it's a bit of a long read. There's a couple issues that they come into. So first of all, kind of explaining the whole container setup, they're looking at trying to escape the kata VM. And so the way these build pipelines are set up, they do have a graphic here. The idea is, first of all, with kata VMs, the idea is to kind of have a more secure VM. Lightweight container runtime that feels like containers but offers much stronger isolation. And then inside of all of the VMs, that's where they'll run all the containers. So I want to say their backend here was QEMU VMs, and then all of these containers ran inside of it, including your actual build. So Bitbucket kind of being like GitHub, but not. It's from Atlassian. Obviously offering the ability to run builds when you commit, whatever. So breaking off the build container itself was fairly easy. Privileged Docker container, use the no-one technique to get out of that. But one of the things they wanted to ensure with this more complicated setup is that you could not interfere with other users and other users' builds that are happening on the same kind of container host. So you have this isolation between the different hosts. So what they found was that inside of the build container, the Docker, the user bin Docker, would get mounted in there, and it was mounted as a read-only file. But what they found once they escaped that build container and they were just sitting inside the VM, the Docker executable was actually in a read-write mounted folder. There was just this general folder that had a bunch of things, including a mount to the read-write Docker. So once you escape the container, you can go ahead and just replace Docker with anything you wanted, and all the other containers on that coming from that same container host would use that tampered Docker. That was the first vulnerability that they reported. They did also start looking into getting a full VM escape, which I thought was a little bit more interesting. Again, it came down to things being mounted that maybe shouldn't have, or in this case, I guess the mount was necessary, but what they found was that there's this log directory. Let's see if I can find it here. Var log pods. So basically all the pods, and then namespace, pod name, whatever. had a directory there, and it had the output for every file just being, or the standard output for all of the builds and services, whatever else, would be written into 0.log, so standard out.log. It's written there, and then the containerd service on the host was actually, a process on the host was writing to these logs, and containerd would also kind of have it open, doing things there. That's being used for like the web UI and things like that. But anyway, something on the host, though, was writing to these log files, getting the output from like the Docker run or from the container run, whatever, writing them into these log files. So what they found is that they could just go ahead, since it's a read-write mount, go ahead and replace that 0.log with a symlink to some other file, which would actually give them, because it's being written by something on the host, when the host tried to write that symlink, it would go ahead and write to any other location, it would go and write to any location that it could on the host, allowing for kind of a container escape. It was a little bit trickier with that, just because containerd would basically ignore errors. So when you replace the file, when you replace that 0.log with a symlink, it wouldn't reopen and actually follow the symlink. It would just get an error when it tried writing. And with that error, it would just ignore it. So what they found was they could take advantage of the log rotation system by creating a file that is greater than 10 megs. It would see that and be like, hey, we need to rotate this log, rotates it, and then tells containerd to reopen it after it does that rotation. And if you could erase that, where it would get rid of the log file and then come back with, and then tell containerd to open it, you can basically erase it, create your symlink before containerd opens it, but after the rotation has happened. And at that point, you can get to go ahead and write out to any file on the host. What they didn't get the chance to do was actually find a target for the script to write to overwrite some script that would be executed. Part of the challenge with that is because the file being written, I believe the permissions on it were owner read write, but not execute. And group and everyone were also had no read write access, sorry. So that made it a little bit challenging. They didn't have the time to actually go through and find it. It ended up getting patched before they could find any proper target, but there's a reasonable chance that some script might have been getting executed directly, just calling bash and file name, that they could have overwritten with this. They didn't go through it, but that would have been how you'd get the escape from it. But yeah,
you could also try to hit like a config file or something too, possibly.
Yeah, there are some other places you could look to try and config. Like, I guess actually, since there's that log rotate, I know we've talked about RC through log rotate before, through one of the actions. So depending on, I doubt it was using the normal log rotate that we used when we talked about that vulnerability. But it would be something, you might be able to do something similar if they have some sort of config actions like that. But yeah, they didn't get the chance to do that, so we don't really have information on how you could have escalated. Just, they had an arbitrary file system, right? Which is a fairly powerful primitive for trying to escape.
Yeah, it sounds like a pretty cool attack that involves some pretty clever tricks. So, yeah, definitely, like, sounds like there was some cool stuff to read in there. Like you said, though, it is like really long, and that's kind of what got me too. Is it was long, so I was going to get around to it. I kind of procrastinated a little bit, and then I ran out of time. So thanks for covering that one. So next we have a real fast issue on X Screensaver on Debian through Project Zero. It's an issue where the X Screensaver app has the CapNet RAW capability, which allows you to open RAW sockets. That's usually a privileged functionality because the ability to create RAW sockets and send your own packets on them is pretty sensitive. It opens up a whole new area of attack surface for parser bugs and whatnot, since you can control data at the the protocol level. So very straightforward. It was basically just an exposed capability that shouldn't have been exposed, right? Just a permission that wasn't tracked properly.
Yeah, I mean, it's kind of funny. just the fact that you have a screensaver that has cabinet raw access on it. Like that's a little bit more than what you'd expect. Apparently there's a screensaver that was like this sonar, but it would show different IPs you're communicating with, and that's why it would use it. It's just excessive. It's old, but it's definitely kind of excessive.
Yeah, it kind of breaks that rule of only giving permissions where needed, basically.
Yeah, least privileges.
Yeah.
I thought Tavis actually found it. Yeah, I'm going to open up a tweet from him.
Oh, did he have
yeah, so he tweeted about the vulnerability too.
Okay.
And had a little screenshot basically of doing a using sonar, using this screensaver to run a TCP dump without needing root.
That's awesome.
But he also has a video of the actual screensaver that was the source of this. Or at least I thought he did.
I'm just looking at some of the replies. Oh no, not X screensaver again.
So I did think that the screensaver itself at least looks kind of interesting. I've got it up on screen. Obviously, those of you listening to us can't see it. But as I said, like a little screensaver that would show the IPs being connected to and have them ping up on there. Kind of a fun idea, but how it's implemented is just a little bit excessive. Fun vulnerability, though.
I will say, like, that is a really neat screensaver idea. But yeah, that's funny that it led to the vulnerability. So, all right, we'll jump into a bunch of our Windows issues. So our first one is reverse engineering TCP/IP sys and discovering a vulnerability and trying to exploit it through patch diffing. So yeah, this was a vulnerability that was fixed in February in the TCP/IP.sys kernel driver. So they reverse engineered that patch, tried to figure out what the issue was, and ultimately wrote a POC for it. Though it's not a POC for code execution because the bug is ultimately a null dereference, which is usually it's not really exploitable these days. There has been a few exceptions in the past where we saw one where it was possible to maybe get around.
Well, so that you're thinking of that Brovin post, the DOS RC.
Yeah, right, I am. I was kind of thinking about that when I was talking about it. I was like, wait, wasn't that
North Koreans?
Wait, wasn't that one of the North Korean actor posts?
We've got to reference that again. And that one, I mean, DOS RC was very much a bad name for it because, like, the actual vulnerability wasn't a null dereference or a denial of service to take advantage of. With this one, though, there's a ton of reverse engineering and, like, the process I went through to figure things out. Vulnerability itself really ended up coming down to just the fact that when it created this net buffer, it would actually, sorry, I'm going off topic. I had actually gone and interrupted you more to mention that the DOS in this case, while it is just a DOS and it's not RCE, it's a little bit more powerful of a DOS because this is something you could send over the internet. I could just send you this packet and crash your computer, presuming you were running Windows, which a lot of people are. Like, single packet to kill the entire computer is a pretty powerful exploit, even if it's just the DOS and not code execution. It's the type of thing that could definitely still be abused, especially by script kiddies to just spam it out with or something. But the actual issue came down to the truncation. When it would create the net buffer, it would pass in... Let me see if I can find the function here.
I think it was the header and options length, right?
Yeah, so it would pass in the header and options length, but specifically it would send it in as a 16-bit unsigned integer. Rather than, I'm not actually sure, I think it's 32 bits. Yeah, it was a 32-bit.
Yeah.
It would send it in as a 16-bit one when it would call this netio retreat net buffer, which is effectively kind of the first initialization of it. So that would end up setting the data size of it to the 16-bit value. So if the header and options length was actually greater than 16 bits, it would get truncated. But then when the NDIS get data buffer, so that's you you've got this net buffer, and now that function's being called to actually get a pointer to like a contiguous chunk of the backing buffer inside of that net buffer, basically. You'd call that, it would call it with the full size, that full 32-bit size. And that would create a disconnect. It would look inside there like, hey, is the size that they're asking for, which is what that argument is that greater than the size of the actual buffer that we have? Since it is, it's like, hey, this is an error condition, it would return a null. But as you can see in this code, it just does buffer equals and takes that buffer right out of the endis response. It doesn't check it for null, creating that nullity reference when it actually tries to write the value to that buffer.
Yeah, it just derefs the pointer without doing any checks on it.
Yeah, so the vulnerability is interesting, but also not easy to see how to exploit that, because that's just the header and options length of your packet. You need to get that greater than like a 16-bit unsigned int, which standard system and over the internet, you're not sending a packet that huge. Like maximum transmission units usually something like 1200 1500 bytes, give or take, whatever. Like, you're not getting something that big. So the actual way they went about that is using recursive fragmentation, which there's a second post that they shout out here. They have a link to from Quark's Labs, which I think covers the fragmentation aspect a little bit better, or at least visualizes it.
Yeah, the way packets are structured is really like complicated and is not like the same every time, right? Like the way you structure the headers is going to be dependent on what protocol you're using or whatever. So it's
no. So the IPv6 headers are always going to be the same, and then like the lower protocols, like your application layer protocol, is just kind of inside the data segment of the IPv6 header itself. So this is still within the IPv6 header. But what they did with the fragmentation to do recursively, so if you just sent a normal, so of course when you run to an issue where you're dealing with the maximum transmission unit, you need to get around that. Fragmentation's kind of where you should go. The problem is, even when you fragment it, that header and option length is still going to be limited by your first packet. Like, you can't, in theory, you can't really split that up over several packets, because that needs to be included with every packet. It'll send this IPv6 header, then the fragment header, and then data. So it needs to include that part every time, or at least some of that every time. So you are limited. So they fragment one packet, and then at the start of all of the fragments, it would have a second fragment packet or header inside of the fragments. So it would reassemble and then see like, oh, this needs to be reassembled again out of this buffer. So it basically just recursively end up fragmenting the packet, which I thought was a really neat trick to get around that. And that recursively created packet could have like an endless size for its headers, allowing them to get it large enough to be larger than the 16 bits required for the truncation to create that disconnect where the 32-bit and 16-bit values are used.
I did want to say also, thank you, Sodding, for the raid. Welcome in, everybody. We were a little bit late on that because we were covering the issue, but yeah, I did just want to put thank you out there.
I apologize, I missed that here. I'm not getting the audio through when raids happen, but yeah, thank you for the raid.
Yeah, no worries. I didn't want to interrupt you while you were covering the issue. So yeah, it is like a really long post with essentially a null deref. Like you said, though, the impact is a bit, more notable than you might think because it is remote. That's why the title includes packet of death. But yeah, I think what was cool was the reverse engineering aspect to it, which is something we don't cover on the show a ton because we typically cover stuff where the source is available, or even when it's not, the post just kind of skips over it and hand waves it like, yeah, we did some RE and found that it did this, and they keep it very specific to that one, like exactly where the vuln was. So where this post goes more into like the patch diffing and their thought process when trying to figure out like where the bug was from, and trying to figure out like, not from a black box perspective because they had symbols, but I guess kind of like a gray box perspective. So it was cool to kind of get that shakeup of covering reverse engineering when we don't always get to. And that's true with a few more of our topics today too, actually, due to Windows being such a prevalent topic this week. So yeah, I mean, with that said, we'll jump into our next Windows topic, which is exploiting system mechanic driver. So this is one of those maintenance products for doing like system cleanup and whatnot, like active care. I mean, a lot of those products I think are like scams, and I don't think people should be using them anyway. But I don't know about this one specifically. Maybe it is a useful tool. I'm not sure. But yeah, VoidSec ended up looking into this product. So again, because it's Windows, it touches on that reverse engineering aspect to finding vulnerabilities. They talk about how they reverse engineered to find all the ioctls that the driver would expose that this program used. And then once they found them, they did some fuzzing on them using ioctl BF, which is a basic generation-based fuzzer. Within seconds of launching that fuzzer, it found an access violation, which turned out to be a null dereference, though the bug was actually more powerful than that. The null dereference was basically a side effect of a larger problem. I believe the core of the issue came down to the fact that there's an object that resides in user space that gets read in from the kernel in an unnamed subroutine that gets called by various ioctl handlers, and that object contains a pointer that gets dereferenced and it just gets trusted by the kernel for some reason. It's like there's like no checking on if that pointer is actually a user space pointer, so it can get you arbitrary write in certain paths. Depending on the ioctl that you call.
Yeah, I mean, it's arbitrary write. You don't really control the value being written. It's just whatever the return value is. So 0xFFFFF. And last character looks like an E, I guess. I think.
Yeah, it is.
Yeah, so that's what gets written, but you end up controlling where it is. They go into like reverse engineering that structure a little bit. How like it'll use an index offset at one point. Like they cover this structure. But the gist of it is, as you said, ultimately you have this one call that basically just writes out to whatever address you provided, as long as everything else seems legit. It'll write that negative, like 2 or whatever that value is, out to wherever in memory you want it. Which is a pretty decent primitive to have. They covered the exploit strategy, nothing too special, overriding token. They cover the KASLR bypass, but effectively, yeah, just overriding it with maximum privileges.
Yeah, it's crazy that it's like 2021 and we're still talking about kernel just trusting pointers outright and not doing any checks on them. Like this.
Well, this is a bad driver. Lots of bad drivers, especially Windows.
Yeah, it's just like even I know it's Windows driver, but this is still like inexcusable with. Like, you don't just take pointers and trust them, but, whatever.
Seems like a lot of Windows drivers do just take pointers and trust them.
Yeah, it's wild. It's wild in Windows world. I don't know. But, yeah, so the reason the crash got triggered was because the ioctl that was taken by the fuzzers zeroed that buffer, so that's how that null pointer ended up getting created. Like Z said, it is a constrained write. You can't just write whatever you want, but because of they basically abuse that return value write in order to write into the present and enabled privileges on the token structure to get LPE. So yeah, cool exploit strat. Not a very cool bug though. Like that's just man, trusting pointers in 2021, crazy. All right, we'll get into our next Windows bug, which is also not the last one. We have another one after this too. This one covers an out-of-bounds write in the desktop window manager DLL. And it involves the direct composition API in Win32k. So basically the way the pipeline works for getting to the desktop window manager is you invoke these system calls in Win32k to create channels, process channel batches, and commit to the channel. And then those get serialized and sent over to the desktop window manager. There's a few problems in one of the commands you can pass for setting that resource buffer property. And that command can take like expression types such as like a direct draw surface vector, I believe. And it'll either like add a new property to the resource if one under that ID wasn't already defined, or it'll update it if it's already there. One of the issues is the fact that you can add properties to a resource and cause it to fail if the property ID and storage offsets don't match, but it only fails after adding the property. And this happens in both the DLL and in Win32k. The other problem is the fact that the update flow path in the DLL doesn't check if the property ID you provide is less than the total number of properties that's being tracked, though that check is done in the kernel. So by combining these two issues, you can basically cause a desync. You can inflate the kernel property count so that it's higher than what's in the DLL that it gets in the window manager DLL, and then use that to abuse the update path in order to get the out of bounds write past the buffer used for properties. There are some other things you have to account for. You have to satisfy some conditions on some out of bounds reads that occur first that do checking on like the storage offset and property type. But you can get around that by doing some heap grooming to get controlled data there, which they do using the same command actually.
Yeah, they kind of hand wave over their grooming technique. Like they just kind of mention create the large resource to get heap into specific state. Like if you understand heap grooming, this is all pretty understandable. Basically, spamming it, like say, get large into like so you kill off some of the randomness. And then they're creating gaps and then hoping that the gaps get filled. Like it's a pretty standard technique. I just felt like it almost hand waved over some of it.
It would have been nice if it covered that a bit more, but
you can get that sort of information out of other write-ups too.
Yeah, they focus more on the like vulnerability than the exploit dev side, which is fair.
Yeah, totally fair.
Yeah. So this vulnerability was discovered in the wild, so obviously it's exploitable. When analyzing it, they believe it's the same APT group, the biter or whatever, which abused a different 0-day, which we also covered back in episode 64 in Win32K. So, you know, we have a recurring guest, I guess, in the form of an APT group. But yeah, it's a bit of a complex issue. Basically, this attack wouldn't even be possible if they did some sane checking on the add property flow so that it checks the property ID and storage offsets before actually committing the property addition. So yeah, there's kind of two issues there, I guess. And it mainly just comes down to the DLL and the Win32K having slightly different code. It seems like it's basically a copy-pasted code. And again, this kind of points to why centralization is key to move towards, although I'm not totally sure how you do it the way they have this set up, because you are dealing with like a user space and a kernel component, so it would be tricky to try to centralize that. But yeah, like where you have code that's copy-pasted, if there's one change made in one code base, it's easy for it not to make it to the other one, and that's basically half the battle with getting this issue to occur. So yeah,
I mean, part of the thing is like, in theory, without that add issue, this kernel check would have been sufficient. It's just because you're able to create that disconnect where you're adding properties without having them count properly. Because you can create that disconnect, that's where you're able to exploit the secondary one, the update property, but that check is sufficient. Like, assuming there's no other vulnerabilities, the fact it does the check in the kernel, like, that works. That's all you need to do. If it fails in the kernel, it fails in the user land too. Or it never hits the user land.
Yeah,
so they don't necessarily
early,
they don't necessarily need to centralize it and have the same code. Like in this case, because of another vulnerability, the fact they don't check it creates a problem, but
it is a weakness nonetheless, though. Like, they should probably check it in both, but I get what you're saying. Like, without the other issue, it still wouldn't be a problem anyway. Or not an exploitable problem, I should say. So, yeah. We'll get into our last exploit topic for Windows, which is from Project Zero's in the Wild series. It's a heap overflow in Windows Defender. It's essentially a parsing bug when trying to unpack ASP or AS protect packed executables, which we've covered before, issues that have sprang up from trying to parse these custom packed formats. I'm pretty sure from P0, actually, though I don't remember the exact details, but I know we've covered at least one before. So this issue was when parsing section entries. It would only check that the next section's entry address is lower than the previous one. It didn't check if they're equal, though. So if you have two entries with the same address, you get one entry that has a 0 size, but then the next entry it sees, if that has a non-zero size, it'll try to copy data there when nothing actually gets allocated there. So you kind of get this copy into a hole, basically, which can be abused for smashing the heap. They think this issue was likely found by either fuzzing or manual code review. I'd edge probably toward fuzzing if I had to pick a side. This type of issue is prime for the type of issue that a fuzzer would detect quickly. These kinds of parsing bugs.
Yeah, I'd agree, but at the same time, this sort of issue, just not checking for, basically not handling an else. That's one of those things that stands out doing code review too. So like I could see it happening on both. I kind of agree. I'd put this more likely on the fuzzing, but I think it's pretty reasonable to say it could have been review also.
Yeah, which is fair. They also detail the exploit strategy of how you'd be able to get arbitrary read-write by using the original overflow to trigger 2 more out-of-bounds writes. First on an L-find switch object, then using that to perform an OR operation on a virtual memory manager context structure field. And that field is used for tracking the length of the table for tracking virtual pages, which can then lead to additional out-of-bounds reads and writes, which you can use to smash another memory management struct to get arbitrary read-write. It is a little bit like, because it's these in the wild posts, these are usually quite concise. They just like cover the vulnerability and the exploit strat. They don't really cover a ton of background info like we get on all the P0 posts. So the objects they mention there, if you're not familiar with like Windows and those objects, then that might not mean much to you. But basically what they're hitting here is the virtual memory manager. They're trying to chain together primitives in order to hit that structure, in order to abuse fields in that object, because when you're managing virtual memory, you have a lot of sensitive pointers in there. So yeah, they use that to get the arbitrary read write, but they kind of hand wave like those objects and exactly what they do. So yeah, I thought I'd point that out quickly.
Yeah, I kind of appreciate these really concise reports that don't take too long to understand just what the issue was and how, well, maybe not how to exploit that, might take a bit more digging, but I appreciate these posts. I will also mention, if you see the disclosure patch date as 12th of January, this is another one of those cases where it might have been written on that date, might have been disclosed or even patched on that date, but we didn't get this report until more recently.
Can't trust the dates at all anymore. But yeah, they talk about some of the improvements that could also be made to harden this area of code. Noting that the NP engine from Defender could be built with SAN to catch these issues faster. Also noting that open sourcing this unpacking code could be useful for killing these issues faster. So like their improvements is mostly suggesting stuff on the vuln research angle, not so much on like the mitigation angle. They also say that Defender emulation should be running inside of a sandbox, which is weird because apparently Microsoft put out an article in 2018 saying Defender can run in a sandbox, but it just doesn't by default, I guess. So while they had the VR suggestions, they also suggested to try to sandbox these parsing routines away, because when you have all these like custom packing formats and you're trying to deal with them, that just seems like a never-ending attack surface. So it makes a lot of sense to try to throw that in the sandbox if you can.
Yeah, it's a process that's dealing with untrusted input. The untrusted input happens to be these binaries, but it's still untrusted.
Exactly. So whenever you're dealing with that much untrusted input, it's easier to just throw it in the sandbox if you can. And like I said, like it's weird that they don't, especially with something like what Defender's threat model is. The fact that it can run in the sandbox and it doesn't is a little bit weird to me. That said, there might be some... It could be performance or some other issue where it's like, for whatever reason, the way they designed it, it's tricky to do certain things. So like, even though it technically runs in a sandbox, maybe it can't communicate properly outside of it. I don't know. I don't have the necessary like Windows internals knowledge to really comment too much on that, but I thought that was kind of an interesting sentence to highlight. So we'll get into our last exploit topic, which touches on exploiting a Chrome end day on a Tesla Model 3. We don't cover exploits of older bugs too much on the podcast, especially ones that have had previous exploits written for them with like a year ago or whatever. So I won't really dive too much into the exploit details, but it's basically about porting an existing exploit to a unique target, being the Tesla. I will touch on the bug quickly. It's a type confusion when doing side effect modeling in Turbofan, which is optimization stuff inside of V8, which, to be fair, like I'm not well versed in the optimization routines of browsers. That is like a really complex subsystem. The way I understood the vuln from a high level perspective is it'll try to infer like a map of objects, which is essentially like the type. But that type can either be reliable or unreliable. And what makes it unreliable is if a call can have side effects and like taint the object. Well, if a call has side effects, but it mistakenly gets marked as a reliable by the optimizer, that's where you have some of this trouble and the basis for this bug. There's a missed case where the function that gets called, which is kjs create, gets reached. It could mark results as reliable when they should be marked as unreliable. So by inlining a function that pops values out of an array using reflect.construct, which uses that kjs create function pathing, you could create a type confusion on the array, switching it from an array of integers to an array of doubles, which, while it may not sound like much, remember that browsers are like absolute monsters when it comes to internal state tracking, and those types of arrays are very different with how they're handled under the hood in the engine. So by being able to cause that type confusion, that is absolutely enough to get code execution. So yeah, basically what they did was they exploited they used that to corrupt the length of the float array to get out of bounds right, which they worked to get the popular address of and fake object primitives, which are basically the end game in browser exploits. I'm not going to cover that here, but if that sounds interesting to you, you should check out Salo's frac paper on attacking JS engines. It does a really good job of explaining those primitives and why they're so powerful. But yeah, the researcher discovered their Tesla was on an outdated V8 that was vulnerable to this bug. When they tried running the weaponized exploit, though, it didn't work, but they noticed the POC of the original bug still triggered a crash. And it was kind of funny. They discovered that the browser was actually too out of date because it didn't contain a feature that the exploit that was written for this issue abused, which is called pointer compression. Pointer compression is basically where they take the upper 32 bits of a JS object pointer. They store that in a register, since that isn't going to change throughout the runtime, and then they combine it with the lower 32 bits, which are stored on the heap, to form the final address. And that's presumably to save space on the heap, I guess. I don't know all the reasonings behind it, but that's the most immediately obvious reason to do that. The reason this caused issues, though, is because they were using an array of doubles to smash a pointer. Now, because that pointer compression wasn't there because the browser was too old, the double was no longer the same size as the pointer, since it's not compressed anymore. So they could use a lot of the exploit, but they had to change how the address of and fake object primitives were obtained, because the way Exodus originally obtained it was by allocating an object next to the corrupted float array in memory, using heap spraying and leaking the value through an inline property. And similar to get read write, they pushed an array on the array to corrupt an adjacent stack of backing store pointers for like a UN32 array or whatever. So all the author had to change really was with the leak primitive. They had to make it so that it leaked addresses by popping from the corrupted float array instead of trying to read out of bounds on an adjacent object. And they used a similar strategy for the read write. They pushed on it to smash a backing store of a UN32 array. Finally, they used WebASM shellcode for code execution. Doesn't really touch on that part too much, but yeah, I mean, the most interesting point from here was the fact that they noted that Tesla was running x86-64 for the instruction set, which is really interesting. Like the author said, I was kind of expecting like ARM or ARC64 for the chip that was running where the browser was coming off of, but yeah, it's running an x86 chip, which makes ROP and everything and shellcoding like a lot easier, because you can test it without having to emulate a different ISA. But
yeah, it's definitely an interesting aspect to it. Like, I wasn't really expecting Tesla to be running x86.
Yeah, super strange. ARM, like an ARM chip makes a lot more sense, right? Like a lower power chip, but yeah, that's just what they decided to go with, I guess.
But I mean, yeah. Tesla, you want high power. I don't know. I mean, like, I could see the argument on the low power side and going ARM for that reason. At the same time, perhaps, I mean, development time could be a little bit quicker going off x86, perhaps more libraries or something you could use. Perhaps some sensor that they worked with, like, I'm not sure. Or as Memorious IT in chat says, make it play AAA games.
I'm reminded of that Joe Rogan interview that Musk did where he was talking about all the secret Easter eggs they put in the Tesla with like games and all that stuff. Maybe that's why they used an x86 chip. It'd be really stupid, but I mean, that would be a pretty funny reason. But yeah, like it's not a new bug or a totally new exploit, but it is fun to see how an exploit, like a browser exploit, gets ported to different targets and some of the roadblocks that can get hit while doing that. I have kind of a special place in my heart for that kind of stuff from console stuff too. So, yeah, interesting post to read, but it is kind of an older exploit. And there are other resources like the Exodus write-up if you want more information on the core of the bug and how it was exploited originally. So, yeah, that post mostly focuses on the porting. All right, so that pretty much concludes all of our exploit topics. We'll move into our shout-out section of the show. I don't have any, but Z has two, so I'll let Z cover his shout-outs, and then we'll wrap it up.
Oh, no, I think the second one was your link.
Actually, you're right. Sorry, I'm forgetful.
That
you
said,
are correct.
Yeah, I've got... This one's just a fairly brief blog post. QEMU and U from Atridus Security, I think it's Atridus Security. They're security research, pen testing, that type of company. Talking about doing basically whole system tracing using QEMU. I thought it was just interesting, gave a bit of an insight into, one is a bit of how QEMU works, and then obviously how you can use that to start writing your own tracing implementation stuff. I just found it to be an interesting read, not really an exploit, but still related to doing the vulnerability research. So want to give that a quick shout out.
And the shout out that I was going to give away to Z that I forgot was actually mine is a blog that somebody posted in the reverse engineering server a couple days ago. This contains a bunch of posts on various topics, like some CTF write-ups, but also like some fuzzing based stuff, binary analysis, doing some like trace analysis, and some stuff on the ELF and portable executable formats. It's nothing too like advanced, but and it is a bit old. Like a lot of these posts are from 2020, like February and March and whatnot. But it contains, like, the way these posts are written are very accessible to people who are not familiar with the topic. So I wanted to shout it out because I think this is a very good beginner resource, and I was like really glad to see this blog, especially like when I was looking into the fuzzing articles. Fuzzing is a little bit hard to wrap your head around if you're not already familiar with the space, because there's a lot of like invented terminology and stuff like that, which I think these posts do a good job of covering. So if you're looking to get started and you want to look at one of these topics, like binary analysis or fuzzing or whatever, these posts are definitely worth checking out for getting some background info on that topic without having to read something that assumes you have a lot of knowledge or something. And that's not to say that the posts are simple. It's just they're really well written for anybody, right? They're very accessible. So I wanted to give that a quick shout out.
Yeah, I had looked at it after you passed the link over, and I have to agree, like, looks like there's some good information on there. Obviously I haven't read everything, but no, it looks solid.
Yeah, for sure. That said, though, that's all of the topics for this week. Thank you to everyone who tuned in. You can catch the VODs on Twitch or on YouTube, as well as Anchor. We're on most platforms that are common for podcasts. Follow us on Twitter and join our Discord for notifications and to join the community. With that said, we'll be back again next week at 3 p.m. Eastern, 12 p.m. Pacific for the Day Zero podcast, and we will see you guys then.